I'm going to describe how to use interactive simulation that does mass balances on evaporative crystallization. And so the simulation page will look like this, where when we open it, we have in green the unknown values. In this case, the unknowns are the mass flow rate of the feed, which is a solution of KCl and water, and the mass flow rate of the KCl solution that's leaving the system mixed with these crystals. And the system consists of an evaporator where we remove water, so water flow rate here, and then we crystallize out KCl, we recycle the remaining, which enters the evaporator, and we run at steady state. And the idea is that we can adjust these two sliders here and here to what we think are the correct values for these flow rates. And the way we determine those is by doing mass balances. So we have two unknowns. We can do two mass balances. In this case, we can do a balance on the overall system, namely the mass coming in must either leave as water vapor or as KCl crystals or as KCl solution. So that's one mass balance. We need two mass balances because of two unknowns. So we can do a balance on the KCl, and that means the feed rate times the mass fraction would tell us how much KCl is flowing in per time. It's leaving in two places, mass 4 here KCl, and then mass flow rate 5 times the mass fraction. So two equations and two unknowns, we can solve them, and then we select solution, check the solution box, it will give us the correct values. We can compare to see if we did calculations correct. Now when we hit new problem, then it comes up with different numbers, and it also can come up with different unknowns that we're trying to solve for. So here's the simulation, and in this case you can see we have the mass flow rate of the crystals unknown and the mole fraction. If we solve the equations, we can input our values using the sliders, and we can also, if we want, click and then type in a value if that is easier. And then I'm not going to solve them here, I just put in random values, and then we can do the solution, and it tells us the correct values so we understand if we're doing the mass balances correctly.